And today we'll be doing our Increasing Throughput 101 webinar. This webinar will show you how you can increase your speeds and modulation rates using RF Elements horn antenna technology. So if we look at some of the challenges that we've been facing in this industry, one of the challenges is the demand for throughput. Over the years, not only have we seen a very steep increase in the number of internet connections we need to deliver to customers, but on top of that, we have seen a huge demand for the actual speed per connection as well. So when you combine the number of connections and the increased need for higher and higher speeds, it's becoming very challenging for us to, as WISPs, to support these the user base that's out there. One of the other challenges with dealing with this increased demand for more speed and more connections is the lack of spectrum that we have. So not only do we have a limited spectrum where we can operate in legally DFS, non-DFS types of spectrum, but the amount of noise that has come up in this usable or legally used spectrum has made it much more difficult to operate in, again, due to the high amounts of RF and interference. And to date, wireless vendors, continue to bring more advanced technologies and very complex solutions like GPS synchronization, TDMA, active filtering, and all these different things to try and address these issues. But really the results of that is really not sufficient because they're not dealing with the issue at its roots, which is mitigating noise and rejecting interference with antenna technology. So again, the noise issue is not really being addressed at its roots. Rather, they're dealing with the consequences of what's happening out there, which we feel is the wrong approach in dealing with this issue. If we look at some of the solutions that are out there for interference, we can see there are really some poor solutions out there. Mainly, a lot of them happen to be these aftermarket third-party shielding kits. And these shielding kits are really a bad idea, and they don't work very well because they only address kind of the co-location issue of APs in a tower. But what ends up happening is it inadvertently affects the RF performance of the sector. Once you add this kind of metal shielding around the sector, it changes the beam pattern, it changes the RF performance of the sector, therefore reducing the speeds that you have and making it harder for higher modulation rates to stay connected or to be connected. We also see a growing complexity from the radio manufacturers in types of radios. We started with 802.11n, which are kind of just generic radios. Then we go into kind of bringing GPS sync onto the scene, which adds cost to your AP. And then we go beyond that with radios now that have active filtering. And again, these extra costs could be mitigated if you just use proper antennas. So these extra functions and extra features, again, add cost to your bottom line that really aren't necessary if you deal with the noise issue, where it starts, and that is improper antennas or poorly designed antennas. At RF Elements, we deal with the source of the problem at its roots by designing antennas that reject noise, antennas that have zero side lobes, antennas that have clean radiation patterns, antennas that have balanced chains in vertical and horizontal, so that way you get the best performance. We also take it a step further by using our twistport ecosystem, which introduces a near zero loss interface from your radios into your antenna. So when you combine these two solutions together, this is how you get, again, the most spectral efficiency, the most noise rejection, and in a lot of cases, not needing those advanced technologies that are being put into radio systems today. So if we look at noise rejection, right, we'll kind of look at noise at where it comes from. So here on a kind of traditional sector, this is what their two-dimensional and three-dimensional beam patterns look like. So if you look at the sections in red, this is where noise comes from and also where noise is received from. So these side lobes that come out of antennas, these are secondary and third, antenna radiation patterns other than the main lobe where you actually want RF to go. These radiation side lobes are of some high gain, so they're capable of sending noise in directions you do not want. But more importantly, there are huge receptors of noise. So by eliminating side lobes, you can greatly reduce the amount of noise that's generated from your access points, and you also reduce the amount of noise that is received. So by using a properly engineered and designed antenna, you don't need shielding kits because there's no need to shield them further. They're just naturally well shielded and well isolated. And on top of that, because they have no side lobes, they won't send noise into other areas of your coverage area where you're not expecting it to be. So it's nothing but main lobe connectivity, and you have zero side lobes. The same can be said for other types of antennas, like even parabolic dishes. So here is again the two-dimensional and three-dimensional kind of RF patterns for a parabolic dish antenna. And you can see again the side lobes on parabolic dish antennas are actually quite larger than that of sectors. The higher you go in gain of an antenna, the larger the side lobes become. And you can see that the secondary side lobes of a parabolic dish are of such high intensity that, again, they can communicate and talk to each other from tower to tower, right? Because it really starts to grow. And again, it's not just about receiving noise from other directions, it's also about sending noise. And so if you have a properly designed antenna that has no side lobes, then you can see again how we can start rejecting noise, how co-location on a tower becomes more achievable, and how, again, you can use spectrum much more wisely, and you're able to plan your RF planning for your tower sites a lot more effectively, and it's a lot more efficient when you know exactly where your radiation pattern is going, and you know exactly where your radiation pattern will hear signal from. So this is all very important. If we look at the zero loss system, our kind of twist port, our proprietary twist port mechanism, it's quite simple. We just eliminate the pigtails, right, that are in most radio systems, right? So if you are to incorporate the waveguide feed mechanism onto onto your CPU board, then you can eliminate the failure rate of pigtails and also the signal loss that is in a lot of pigtails as well. So this helps you increase or deliver your TX from your radio to your antenna more efficiently, and therefore you have a much better, a more balanced network. So let's look at a patch array sector. This is your traditional sector versus a horn antenna, and we can see some huge differences here. So if we look at the MIMO antennas today, there's a vertical and there's a horizontal polarization. One of the biggest problems with sector or patch array sector antennas is that their vertical and horizontal beams do not overlay properly, right? So one might be wider, one might be more narrow than another. Then you add on top of that the very complex side lobes and the low performance areas, which is the edge of the sector, the low performance areas of sectors, and this is where problems start to come in. So we typically have a kind of sweet spot in a traditional sector, right? It's kind of the middle of the sector is where the beams are most balanced, where the vertical and horizontal intensity is about the same, and this starts to degrade as you go to the edge. With a horn antenna, the horizontal and vertical beam patterns are practically identical. So you don't have that poor signal performance at the edge of the sector where the chains go in mismatch. And therefore, the gain that you're delivering and the performance of your vertical and horizontal beam are much better matched, so therefore you get much better signal throughout the complete coverage area of a horn, where this deviates greatly with a patch array or a traditional sector. So if we look at kind of noise rejection from, like a deployment standpoint here, right? So you have, your tower access point, and you have all your customers, right? So as you, send out your signal, and you have these areas of noise where noise can come in and where the edge of sector performance is worse, your throughput starts to degrade because you have a large diversity of different types of connections within that antenna pattern. Where with a horn antenna, as we see here, right, all the customers that are within the coverage area will get good throughput because they'll have much more stable MCS rates and more stable connections than a traditional sector. Once we start to co-locate sectors on a tower, we start to see yet another issue, right? So as you, again, use your kind of traditional sector for your coverage area, and then your speeds aren't great, and then your customer density increases, right? So you have to add even more customers. The performance of your AP definitely starts to get degraded because it can't handle the number of connections. Where with horn antennas, you can use more narrow sectors or more narrow horn antennas to cover that same area, have everybody be within the more balanced coverage area of a horn, and therefore increase your AP density for that same coverage area where everybody gets full throughput, rather than, again, having a mixed number of clients on a single wide sector that covers a large variety of different MCS rates, different distances, and stuff like that. So co-locating of symmetrical horn antennas is much easier than it is with traditional sectors, and will give you the AP capacity that we need for delivering the high number of connections and the high bandwidth per connection that we greatly need in this industry, and to be able to, again, compete and achieve our goals of delivering fast, sustainable wireless to our customers. So if we look at the old way versus the RF Elements way, again, this is kind of just putting it side by side. With the traditional sector antenna, they're typically too wide. They accept and generate lots of noise in the, again, side lobes that exist, and also in the low performance area of the sector, where with RF element horn antennas, you're able to deliver much more throughput. You're able to deliver more internet connections in the same amount of space on your tower, and therefore deliver, again, better internet connections to your customers. So it's clearly a much better way and a much cleaner way of delivering throughput to your customers than traditional sectors do. So one of the questions or things that always come up is channel availability. All right, most people assume or they have a realization of what their spectrum looks like based on the type of antenna that they're looking through. So when you're looking at your spectrum through a traditional sector, because it's hearing noise from outside of your area, you may fire up your sector, and there may be competing sectors in other areas, right, that make it seem like, hey, I can't operate, I don't have any available channels, because I can see, for example, on this thing, I have channel 5500, 5700, and 5900 as being used. But when you have a horn antenna, because the isolation is so great and the noise rejection from the edges or from the sides is so great, if you look through your horn antenna, you will find channels that are available. So again, because they don't hear so far outside of their coverage area, channels you thought were not available will become available to you. You will find channels that you previously saw as possibly usable as being very usable. You will see channels that you thought were not usable at all that are possibly usable now, right? So the noise rejection helps reduce the intensity of these other signals that, again, We're there because you're looking at your sector through a sector, which you may have been picking up signal from behind the sector, from the extreme side of the sector. And these things will now go away, and your spectrum will clean up a lot, and you'll have more available channels than you think you do. You just have to look at your spectrum through a horn to realize and see how many channels you actually have. The same thing happens with noise floor, right? So just like your traditional sector picks up other APs and other towers at a much higher intensity because of, again, these really large side lobes, the noise that comes in from other sectors, again, start to raise your noise floor. But if you use a horn that has a very precise radiation angle, again, you can bring that noise level down, not effectively changing it, but muting your AP a lot more to the noise that's out there, because again, it's horns, our symmetrical horn antennas are extremely precise, and you're only seeing, the signal in the area that you're actually pointing, and it's way more depth outside of its coverage area than a traditional sector is. So again, not only will it make more and more channels available, but it'll also reduce the noise floor, where your SNRs will be able to be a lot larger and allow you to maintain and connect these higher MCS rates for these higher data rates and higher speeds that you're looking to get for your current customers. So again, when we start looking at the noise rejection and what becomes possible with horn antennas compared to traditional sectors, it's really this massive scalability is what you get with horn antennas, because you have the ability to co-locate so many more APs on your tower than you do with traditional sectors. With traditional sectors, you're kind of tied in to having these really wide coverage areas, these really huge side lobes, which again start fighting each other and make the radios very inefficient. Where if you go with horn antennas on all of your towers, then you'll start to again increase the number of AP capacity, therefore increasing the number of internet connections that you can deliver, and therefore giving you the massive scalability, because not much has changed with radio technology as far as the number of customers per AP, right? So the speeds have increased, so have the packages, and we're still kind of stuck to that somewhere between 30 and 50 subscribers per access point, even sometimes less. Again, it depends on the size of the packages that you're offering, right? But really the number has not really grown past this kind of 30 subscribers per AP average, right? So the only way to increase your capacity is to add more APs, and with such narrow horn antennas available, this massive scalability now becomes feasible, is now an option, and it's now available for you if you use RF Elements horn antennas. So our technology, again, for fast, sustainable wireless is using horn antennas that have no side lobes, have very precise radiation angles, have the most balanced gain across the spectrum, right? So as you change channel, your gain isn't deviating much. Also, as you change channels, your coverage area isn't changing much either. So horn antennas give you that capability. Our twist port ecosystem, this is again something that's often really overlooked as far as what our horn antenna technology brings you. It's not just about the horns, but it's also about our twist port ecosystem. It's very unique in that it's vendor neutral, right? So our twist port ecosystem allows our antennas to become compatible with most of the mainstream radio manufacturers, whether it's Ubiquiti. We have twist port adapters for practically every radio that's available. If you use Cambium, we have twist port adapters for EPMP 1000 and EPMP 2000. We have adapters for Mimosa and even Microtech, right? So this twist port ecosystem, again, allows you to not just use all these different radio manufacturers, but change technology quicker and allows your network to be more dynamic. When you add these things together, you get that massive scalability again that you really need in order to deliver fast, sustainable wireless to your customers and allow you a path to grow and add more capacity as you need it. Increasing your throughput with our horns, also gives you, some benefits of maybe utilizing your older technology, right, to allow it to last longer, so you don't have to upgrade as much. Because again, with horn antennas having such great isolation, GPS sync is not always needed, right? Because you have more available channels when you use a horn, so you don't always have to reuse channels. There's really no need for these wider channels, right? A lot of radio manufacturers are now going to these 80 and now even 100 megahertz wide channels. Again, they're allowing the radios to go wider in order for you to deliver more throughput, but they're not dealing with the noise issue. If you deal with the noise issue and you have antennas that have great isolation, then you don't require all these wider channels. You'll be able to deliver more throughput on a 20 megahertz channel than you could in a 40 megahertz channel on a traditional sector. So there's no need to grow. This is another great thing that people don't really associate to what horn antennas bring to the market, right? And where you're running multiple 40 megahertz channels, because again, you need more speed, but you're not getting the speeds that the 40 megahertz channel should get you theoretically. You're just getting more than the 20 megahertz channel was getting you, right? When you use horn antennas, you're able to, again, deliver more speed per hertz, right? So you can deliver more throughput on a 20 megahertz channel, and you don't have to use those 40 megahertz channels. So this is how we save spectrum and give you more channels to use. This is where kind of real channel reuse comes in that you're able to use more channels with horn antennas, and really at no extra cost, right? Our horn antenna and twistport ecosystem is really well priced, right? So it's not like you're having to buy this extremely expensive antenna in order to do this. So there's really no extra cost. You get to use the radio you're using, and you get to increase the performance of that radio simply by using our horn antenna technology without having to, again, upgrade all the time to the latest and greatest as far as new technology comes out. So again, increased throughput with horns without having to jump through hoops and do all this other complicated stuff that other people may be doing with their networks. So there's really a lot of information out there on our antenna technology, and a lot of feedback from users, right? So it's not just about me telling you that our antenna technology is great. There's plenty of users out there talking about it. If you join our community at which is our forum, rfelab.com, you'll find a lot of great feedback there and a lot of great it's just a lot of information about users that may have had issues and how these issues were resolved with our antenna technology. So it's a great resource for you to use and join our community and see what other people have been seeing and saying about our products. The next portion is actually our YouTube channel. Again, it's another great resource, my most favorite resource, where again, it's not about us, the manufacturer, talking about our technology and telling you how great it is. It's about users like yourself, right? There's WISP from all over the world that have used our antenna technology. Chances are there's a WISP out there that's dealing with the same exact issue you have, or something extremely similar to issues you may be seeing. And you can see how they overcame those issues. You can see how our horn antennas have impacted their business and helped them grow their business. So a lot of great information on products as well. So check out our YouTube channel for some great information and great feedback on our products and how they're being used. And then stay tuned, right? So we're just getting started. RF Elements has been around for a while, but the past 3+ years now, we've been developing our horn antenna technology. We've had a lot of great new products come out, like now there's a twistport adapter for the AirFiber 5X and the HD. We have new twistport adapters for Microtech router boards that have recently been released. We have our second generation of symmetrical horn antenna, which has been released as well, and our ultra horn. So we're continuing to push the limits on performance and form factor, right? So stay tuned. There's a lot of great stuff still coming from RF Elements. You can find most of that information at rfelements.com. Again, you can find it on our forum, rfelab.com, and we're all over social media, right? So YouTube, Facebook, Google Plus, LinkedIn, Twitter, you name it, we're there. A lot of great, again, social media is probably the best place for you to go to interact with the user base and talk to other users who have maybe had problems with our antenna technology and how they resolved it, right? Because really, our horn antennas are so different than traditional sectors and how they work. It takes a little time to kind of understand the technology before you start using it very efficiently, right? So again, there's a great resource of users out there, as well as ourselves. The employees of RF Elements are on social media, and we'll be happy to help you and work on any issues you may have. You could always contact us direct at info, I-N-F-O, at rfelements.com, again, or find us on Facebook or LinkedIn or Twitter. So at the moment, this is all I have for this webinar, and I'm happy to take some questions here. So stand by here and we'll pull up some questions and see if we can answer them. If you haven't yet posted a question, please go ahead and post them in the little chat window, and I'll get them as we go. So one of the questions are the horns available in both 2.4 gigahertz and 5 gigahertz? At the moment, we only have horn antennas for the 5 gigahertz spectrum. We don't have any available for 2.4 gigahertz. Something we're looking at as a possibility. It's highly unlikely because as you go to these lower and lower frequencies, again, the horns become much larger, and I think 2.4 gigahertz horn could be quite expensive as well. So chances are you won't see it. But right now, 5 gigahertz is the only thing that we're supporting. Okay, so here's another question we have. What's the best practice on adding antennas to the same tower, 2 to 3 feet away from each other, or do horns make it where you can butt them up, right? So it depends, right? It depends on, kind of what your area looks like. So what I will say is kind of the standard right now is roughly about a foot apart from each other is the most dense people are going with them. A horn antenna is still an antenna, right? So like any antenna, the more space you give it, the better. So if you don't have to pack them close to each other, don't. They'll perform even better, right? If you have to, we say about a foot apart is kind of as close as you should get them together. Again, if you're not reusing channels, you're not doing GPS synchronization, they can be closer. If you're using GPS synchronization, then you should have more isolation and therefore give it more distance. 2 to 3 feet, I think, is fantastic. If you have that, use it. Otherwise, like I said, the max that we've seen people, and again, if you go on social media, you'll see tons of pictures of people stacking these things up, and they're pretty close to each other. So 2 to 3 feet would be perfect if you have it as you asked. The next question we have here is noise rejection enhances channel availability, but is it constant and stable? Well, of course not, right? It is. Noise rejection does enhance channel visibility, but nothing's ever stable because you might have another AP go up somewhere else that now introduces noise back into your area. So nothing ever stays as it is, right? But chances are you'll always have the ability to find another slice somewhere else in the spectrum, either higher or lower in the band, to move around. One thing that you cannot affect, right, is the noise that's coming into the front of the antenna, because if you attenuated that, then you wouldn't get any signal, right? So really what horn antennas are fantastic at, and what other antennas do not do at all, is ignore the noise outside of that coverage area, right? So it's about using a 50-degree horn and ignoring the other 310 degrees around that horn, right? So your 360-degree coverage. So it's about noise rejection outside of the area the horn is looking, again, you can't stop noise from coming in the front because it has to accept that in order for the radio to work. So it will definitely become more enhanced, and your network will be more stable because the majority of the noise that's in the area will be rejected by the horn. Do we have any other questions? I've got another one here. So symmetrical horn antennas are out of the box, or they need a scope of some sort to line up and connect the devices. So, I mean, this depends. Horn antennas are extremely precise, right? So the signals drop off very sharply at the edge, right? But it really isn't much different than aligning any other antenna that you do, right? Depending on how you do it, if you have a scope, I guess you can use it. It may help, but typically, just like any other sector that you align, you kind of look down the center of it and you point that bore site of the horn antenna, like any other antenna, at some landmark in the distance. So you don't require a scope or some alignment tools. They are very narrow, so it becomes, you'll have more of these antennas, chances are, on your tower than you had traditional sector, so there's more of them to align. It takes some getting used to it, but you don't require any other device to have them connected or to align them. So hope that answers your question. Is there a list of antennas that are supported using the ultra horn antenna? I don't quite understand that question. So, list of maybe if there's a list of radios that are supported by the ultra horn. So let's just put it this way. An antenna doesn't care, right? So it doesn't care what's connected to it. Our ultra horn specifically is part of our twist port ecosystem because it has a twist port adapter on it. So that means any of our twist port adapters that are supported of any radios, whether it's a Ubiquiti with a twist port adapter, Microtech with a twist port adapter, Mimosa with twist port adapter, or Cambium, they all work. So all you need is the adapter, and these adapters work for all our twist port enabled antennas. So whether it's an ultra horn, whether it's a symmetrical horn, or even our ultra dish, our parabolic dish antenna, the twist port adapters is kind of the standard. So any adapter will work with any of our antennas. The antennas are not made specifically for the radios, right? The twist port adapters, the adapters are what are made for specific radios, and you have to have the right adapter. But once you have that adapter, it'll work with any of our antennas. So they're all supported. And if you go to our website, again, you can go under the twist port adapter section, and you'll see all our twist port adapters and all the supported radio platforms that go with it. I've got another question. Great. Are there any link calculator tools offered by RF Elements? Absolutely. So again, if you go to our rfelements.com website, you'll see a button at the top says, or at the bottom of the page says link calculator. Link calculator is a great tool. We're finding it to be very precise as well as far as the gain performance goes and what's expected. So this is not a link planner like a lot of the radio manufacturers have on their website. It's only a link calculator. So if you go to the link calculator on our site, you'll see a drop-down menu for all our different antennas. So you choose the antenna you want to do a link with. You then input the TX power of the radio, whatever you're going to set that power to. You can adjust the MCS rate, so what modulation rate you want to use, whether it's MCS 7 or 64 QAM for, let's say, Cambium, or MCS 9, which is 256 QAM for, let's say, like Ubiquiti or Mimosa. You can change those values and then input your CPE radio gain, and it'll tell you what's the max distance you can go and still achieve that selected MCS rate. And then, of course, when you drop the pin on the map, it'll tell you exactly what the received signal should be based on the link calculation. Of course, making sure that there's no line of sight issues. This is all purely line of sight. right? It'll tell you what you should get. So when you do your installation, you should have a pretty good estimate of what your radio should see, and therefore you know you're aligned properly. So yeah, on our website, rfelements.com, there's a link calculator. Do we have any other questions? Yep, here we go. Can any user join the RF Elements community forum? Again, absolutely. The more, the better. So just go to rfelab.com and click on the join or the login feature and request an account, and it's pretty much automatic. So pretty easy. You can join our forum, and we'd love to see you there. Are there any events that you are speaking at? So yeah, we have right now, we will be on the Wireless Without Limits cruise, and then Wispapalooza in Vegas is probably the next big event that we're going to do. So if you're going to Wispapalooza in Vegas this October, we'd love to see you come stop by the booth, hopefully see some new technology as well, and see everything firsthand. So we'd love to see you. All right, so that's pretty much a wrap at the moment. Thank you very much for everybody that attended the webinar and spending time with us. Make sure to go to microcom.us's website. So it's microcom.us for further follow-up for looking at product availability. This webinar is being recorded and will be posted on the Microcom's YouTube channel shortly. So again, if you have any further questions, go ahead and email your sales rep at Microcom, or feel free to reach out to anybody at RF Elements as well. Thank you for joining, and talk to you next time. Bye.